In the homework, you are given the matrix A, you are expected to find the vectors which satisfy a certain condition. And the equations, they are going to look like this. AC plus BD, this would be equal to the magnitude of these vectors. So then we'll have that AC plus BD, this would be equal to A squared plus B squared square root times C squared plus D squared square root times minus 1 over 2. Okay? So this is one of the relationships. Another relationship that we can use, and I strongly want the ones that have worked on this exercise, please watch this carefully because you may need to improve this a little bit. So, who can remind me what was this matrix A?
It was 0 minus 1.
0 minus 1?
1 and minus 1 again.
1 minus 1. Okay. So apparently this was the matrix. Now, here we can easily obtain how the value C depends on A and B. In this case, we can obtain that D from the first equation. This is going to be minus B is equal to D. Would you agree here? You can correct me if it's wrong. Minus B is equal to D, right? And the other expression is that A will be equal to, no, wait a second, what this is? A minus B is equal to D. Okay, so it looks like if we start from AB, what we are going to get by multiplying by A, we are going to get for C. Actually, we have no information on C. No, sorry, this is wrong. This is C, right? Would you agree? So we multiply this row with this column, we should get C. So minus B is equal to C. So C, this will be equal to minus B, and D is A minus B. Yes. You can look at this what we're discussing here. You can check this again at home, and probably there could be some small mistakes. But then here we can substitute here for C and D, and we're going to have a single equation with two unknowns. So here we have A times C, A times C. This is minus AB. So it's plus B times A minus B, okay, because D, we obtain it from here. And this is equal to A squared plus B squared times C squared plus D squared. C squared is equal to, what is C squared? Plus D squared, this is A minus B all squared. A minus B all squared times minus 1 over 2. So this is one expression, and this expression is going to produce a pair of numbers A and B such that when they are multiplied with this matrix, they are going to rotate 120 degrees. Now also, Isamura, if you can correct a little bit your solution, if you show it in a better way, you are also going to like it for yourself. And also, including the other friends in the class, I strongly suggest you work on this problem. So, as I showed you the graph, the solution of this problem is going to be a pair of lines that are going to look like this. Okay? So this means that we can have an infinite number of points, which, when they are multiplied with this matrix, they are going to satisfy this condition. Now, what I want you to think about this problem now is the following. For any matrix A, we can obtain a value x, and so let's say here, let this be x0, and this is going to be equal to x1. Okay? Then the angle theta, which is between x0 and x1, okay, it's a function of x0. So, ще го не дозволим на табелес? Джони, конфирмуй ти куш?
Pa.
Okay.
Знаю, x0 dhe x1.
I cannot hear. Say it again.
X0 dhe x1 që shumëzohen.
Yeah, I just want to say that the angle theta depends on the x and x0 and x1, right? It's the angle between the two vectors. And here, I want to say that the angle theta between the two vectors is theta of x0, which depends on the value of x0. So you can say that this is a function of x0. Would you agree with this? Yes, right, because as we can see, we can find some values of which we can obtain a rotation, a pure rotation by 120 degrees. And it looks like the angle between any of these two vectors, at least regarding the rotation effect, okay? Because the vectors can also change the magnitude. So, but then, let me ask you one question. I want someone, one of you raising your hand in the comment section? Who wants to answer? You can click the option of raising the hand. You have 10 seconds to do it. 10, 9, 8, 7, 6, 5, 4, 2, 1, 0. So we go with Lum, thanks. So Lum, I have a question for you. Would it be possible, or is it ever possible that you multiply the A with the vector x0 and the x0 does not rotate at all?
I think there could be some value, but
that's good.
It depends on the value for A and for X.
Yes, that's true. So so it looks like picking up different values for A and B, we can always find different angles. This is imperative. This can happen, and you are correct when you say that there could be a case that when you multiply the A, sometimes the red color is not the best color. So you are saying that A, if we multiply it with x0, we could obtain x0. Okay, so maybe we do not rotate the vector at all. But could the length be the same? What do you think?
The length of the resultant.
Yeah. Maybe not. Let's assume that we don't rotate it. Okay. And I want to ask Alkea. Alkea, do you understand what you are saying here? What we are discussing? Alkea? So it could be possible that when we multiply a vector with a matrix, assuming that we could have rotation and length change, Lum is telling us that it could be possible that we don't rotate the vector at all. Okay, so this is possible, and we're going to see today toward the end of the course how this would be made possible. Now,
Professor, so we have to find the matrix that makes this possible?
No, we have to find the vector.
Ah, okay.
This is a good question. So, I mean, whenever we're writing something down, we should know what is a given and what is the answer. But we assume that the matrix A is independent, and all the vectors which are going to satisfy this condition should depend on this. Okay? Okay, Zamora? Okay, so now let's continue. Last time we spent some good time discussing on the possible change from one basis to another. And let's see. I wanted to cover just one final example. And okay. Let's do this. Now I'm going to erase part of these, but please don't forget what we are discussing right now. We started this discussion from the homework we assigned the last session. And let's review here. So, again, let's assume the exercise is the following. So, the example, we have, if we have a basis B, which is composed of the vectors 1, 2, minus 1, 1, this is one of the bases, and then we have also a basis S, which is, and I want Arkea to help me with the next answer. Arkea, so be aware, we have here 3, 1, and 5, 2. So we have two bases, and with these two bases which are provided, we have to consider, I want you always to think about these problems using this schema that I'm showing you here, okay? Or this is a schema, you have seen this enough, and I want this one to be always in your mind, okay? So here, we have the standard basis, and Arkea, can you help me here? I have a question for you. Arkea, maybe we can have a look at the comment section. I'm having, okay. Arkea is not here. Besmiri? Besmir? Besmir, Dea? Elti? Dea, I have a question for you. So, what is the standard basis? What is the basis of the standard basis? Let me say it this way. What is the basis of the Cartesian coordinate system? Are you going to write rather than using the microphone? Okay, I'm waiting for an answer from there. Of the standard basis, if you have the Cartesian coordinate system, including the standard basis, what is the basis? So here we have a basis B, which can be composed from the vectors 1, 2, minus 1, 1. This here, we have another basis S, composed of 3, 1, 5, 2. Let me see. No, these are the two bases. I'm asking you for the standard basis. The Cartesian coordinate system, X and Y. Think about this one there, and let me ask Elti. Elti, can you help me? Which one is the standard basis? That's correct. So there, have a look at the answers of Elti. And so we are going to write here the standard basis, which is according to what Elti is telling us, this is 1, 0, 0, 1. And let the basis be equal to 1, 2, and minus 1, 1. So then here, this is 3, 1, and 5, 2. Okay, then the question is as follows. Let's assume, given a vector x according to basis b, this is equal to 4 minus 1. This is according to basis b. Given this, find what is x? Find x according to basis s. So how, wait a second, can you explain? Yes, there, the standard basis is composed of, so let's assume that we have the two-dimensional plane. For the two-dimensional plane, we can use the coordinates x and y, okay? And a reasonable choice for the standard basis is the following. Writing the vectors 1, 0, which is this vector here, okay? And writing also the other vector being 0, 1. Okay? So these two vectors inner, they can we can describe any vector as a linear combination of these two. Okay? Is it clear there? So this means that the vector 7 minus 2, this in the standard basis SB, this is the same way as writing just 7, 2 with no indication. If we put no indication, this is the standard basis, but in principle, this means that this is equal to 7, 1, 0 plus 2, 0, 1. Okay? Now, this is because this is a projection, and let me ask also this other question there. So this is for two-dimensional space. This is R squared, okay? If we have the R cube, if you want the three-dimensional space, if you want to describe any point in your room or in the classroom, then we can select the three-dimensional space, which is going to be the following. Here we can have the X, this would be the Y, and this would be the Z. In this case, our basis is going to be, the standard basis is going to be this vector of length 1, this vector of length 1, and this vector of length 1, okay? Now, how would we denote, this, my question is to Dea again, how would we denote these three basis vectors for the three-dimensional space? Can you write them down there in the comment section? There, you have 10 seconds.
Profesora, do bëhet përsëri me këto 1 0 0 1 apo
Well, it better be that way. Ashtu do t'jetë, po.
po i takon përsëri 1 0
Po pastaj?
0 1
Po.
edhe 0 minus 1?
Jo. Këto i the mamu të tjera.
Okay.
Okay? Pra kështu do t'jetë. Pra, nëse kemi hapësirën 4 dimensionale që R4, kush është standard basis për R4? Më thuaj diçka të gjashme.
Si, profesor?
Thuaj standard basis për R4.
1 0 0 0
Shumë e saktë. Pastaj
0 0 1 0
e theni 0 në vonesë tjetër
0 0 1 0
po pastaj
3 0 dhe 1 1 në fund.
Okay, so this would be the case. Okay? So these are, we call this standard basis, okay, because they are clearly showing to us columns which have a magnitude of 1, they are orthogonal, and we have all the weight on only one of the dimensions. So these are all the standard bases. In two-dimensional space, this is the standard basis. Now we come up with two different bases which look like this. If you go to the class recordings of the previous sessions, you're going to see examples of how we can project a single point in space onto different bases, okay? Now, regarding this, we have here, who wants to answer this question? If you like to answer this question there, you can go ahead, or I can pick someone else. So I want another volunteer. Can you raise your hand in the comment section? Not Isabora, someone else? Someone else from the class? Okay, then I'll have to pick you. I can ask Medina.
Yes.
Yeah, Medina, so we have here the vector x, which is given in basis b. So let's remind you, this is the basis b, and this is the basis s. What do we need to do to find the vector x, how it is projected in this domain? This is the question. What should we do? Any idea? Or let me ask you this. How does this vector look like in the standard basis? So we know that, or let's do it like this. Medina, have a look here. We said that this 7, 2 was in the standard basis, right? And then the vector x, this is equal to, what does it mean to have a projection 4 minus 1? This means that this is 4 times the first column, 1, 2, right?
Minus 1.
Yes, times what?
Minus 1, 1.
Yes, minus 1, 1. And this is equal to what?
4.
4, yes, and then?
8. No.
Is it 8?
Or minus 1.
So what should I write here? Ecco, leggiamo? Stato scritto. Okay.
1, teacher?
Say it again.
Ni?
No, we have 4 times 2 minus 1. What is it?
7.
Yes, if this is 7, what is this one on top? This is not correct. Okay.
5.
That's correct. This is 5. Okay, so this vector here, which is 4 minus 1 in this basis, 4 minus 1 in the standard basis, this is equal to 5, 7. That is correct. And this 5, 7, we know that for any basis, if we look at the basis vectors, the vectors that construct the basis, we can make a matrix here, which we are going to call this one PB, the transition matrix of the basis B. Here, we can write here PS, so we have a transition matrix of the S basis, okay? And how can we pass from one basis to another? We can use here the PB, okay? And similarly, we can come this way using the PS, okay? So how did we do it? How did we find the vector x according to the standard basis? This one, according to the standard basis, this was equal to the PB times the vector x as projected in basis B, okay? And then we can also state that we get that this is also equal to PS, this is the transition matrix, times the vector x according to the basis S. Okay, so now I want to ask you again. We have this 5, 7. The question is to find this quantity, which is here in red. What is this? How do we find this? Any idea, Medina? So we have this, this is unknown for us, okay? But we know this side of the equation because it is right here. So what we can do, let's have a look at this problem. We can multiply both sides of the equation with PS inverse, okay? And here, we can multiply also with PS inverse. Would you agree here? Medina, I'm still asking you.
I don't know this one, teacher.
Okay, so let's have a look carefully here. From the last session, we said that we can transform the vector from one basis to another just by multiplying with a specific basis we are given. Okay, so this is PB. So PB here is equal to 1, 2, minus 1, 1. Fine. So what is the first piece of information that you want to pick up once you are given these? The first piece of information is say that, okay, I have this basis, and for this basis, I can construct this transition matrix, PB, okay? Then, we have this other basis. So let's not forget, in the problem here, so we are given also the basis of S. Then here, we can immediately write down that we have a PS, which is equal to, what is this? 3, 1, 5, 2. Okay? Then the next important piece of information that we need, it could moeten nature, să mut nature care ne pas de tjetra. Gjë tjetër që gjejmë direkt është PB inverse. Okay? PB inverse, this is equal to 1. When we find the inverse of a 2 by 2 matrix, first it is important to look at the determinant. What is the determinant of PB? Let's try to write it down. Anyone who wants to answer this, you can raise your hand in the comment section. I would welcome anyone. Cindy, Christy, what does it think, Christy? Yes, Christy, what is the determinant here? Christy?
One minus 2, it's minus 1.
1 times 1 minus what?
Minus 1 times 2.
Yes, minus 2 times minus 1, right? Because this is how we find the determinant. We multiply these two numbers and we subtract the product between these two, right? So
Yes, and that's equal to minus 1.
this is equal to, what is it?
Minus 1.
I think it's 2.
To me, it looks like a 3.
Yes.
Okay, so Christy, stay again here. Do you remember how we find the inverse of a 2 by 2 matrix? So this is going to be 1 over 3 times, I believe we interchange these numbers. Can you correct me if I'm wrong, because I often cannot memorize this. This becomes 1, this becomes minus 2. Is this correct? And Christy, what is the determinant of PS?
3 times 2.
Yes?
Plus 5, minus 5 times 1.
Minus 1 times 5, yes. What is this equal to?
6 minus 5, 1.
1, that's correct. So here we have the PS inverse is equal to what? This is 1 over 1, which is 1. And then I believe we put here 2, 3, minus 5, minus 1. So there is an algorithm where you just interchange these two values and you put a minus sign here on the other side, okay? And it is worth checking whether this is true. So if we multiply this one here with 2, 3, minus 5, minus 1, let's see what we get. This is just for testing. This is 3 times 2 is 6, minus 5, 1. 3 minus 3 times minus 5, this is 0. 2 minus 2, 0. Minus 5 plus 6, 1. Okay, confirm. So they look right. So we found these Christian. Then, so here, from this expression, what is P inverse times P here? What is this, Christian?
It's the matrix so that we found 1, 0, 0, 1.
It is the identity matrix, that's true.
Yes.
So here, we get the identity matrix times XS. Okay? And then, on this other side, if we have a look at this expression, what is X in the standard basis? X, this is equal to x in the standard basis. What did we find?
1, 0.
No. X in standard basis, it is 5, 7. I'm not asking about the basis. I'm asking about this x here. So this is 5, 7. Okay? And we multiply this with PS inverse. PS inverse, we get it right there, which is 2 minus 5 minus 1, 3. So what is xs then? Can you help me here, Christy?
I'm sorry, can you repeat the question?
So what is xs? Can you find? Let's multiply this matrix by this vector. Sad, почнем с этой матрицы вектора вектории. Sad, Christy.
Diet minus 3D.
Минус 30 ps.
О, минус 30 ps.
Sad,
Minus 300 ps.
to.
Minus ps plus niște ni. Działasz mówię. Sztab mówię.
Okay, so here we get that this vector, so this is according to the basis B, and this is according to the basis S, minus 25, 16, according to the vector S, okay? So this is the answer. Now, this became a little mess, but we can try to clean something away, and let's assume, Christy, that, let me erase this. Let's assume that we can come up, so this is the standard basis. Allow me to erase this one, because this is classical. I don't want you to forget this. And let's come up with a different basis. Let's write this one basis T. Basis T, which is composed of, Christy, give me two vectors which can serve as a basis for R squared. Give me two vectors.
Дютра.
Шумер, o.
Это ни минус ни.
A jak to do vector base per recatrorin?
Jo, nu kam vector bas.
Pse? A mund të jenë.
Po, mund t'jenë.
Mund të jenë, pse? Mund të jenë, Kristi, sepse determinanti i matriceve që përbëhet nga dy shtreshi dhe 1 minus 1, sa është determinanti i kësaj? Është minus 5. Okay?
Po.
So it's minus 5. So the determinant is different from 0, which means that these columns, they can serve as a basis for R squared. Okay? That's the only thing we have to look for. So here, let me erase this one. So it looks like you, Christy, came up with a new basis for R squared for the two-dimensional space, which look like this. Then with this basis, let's call this one basis T, letter T. So how can we transfer any vector from here to the standard basis? We move this way with a matrix PT, and we come backwards with a matrix PT inverse, okay? So also similarly, we move, if we come up with another, so the board is becoming a little complex, but let me come up with another combination. Let me call this one matrix K, or basis K. I can come up with a couple of vectors which serve as a basis. These vectors will be 2 minus 1, and the other one, it is minus 1, 3. These are also a basis, and here, in order so that we don't get confused, we always go from the basis K to the standard basis using a matrix PK. Okay, Christine? How do we come backwards? We come with PK inverse. Okay, so now let's come up with a vector in here, or let's do it like this. Let me use this part of the board. If we are given a vector x which is in the basis K. How do we find how this vector looks into basis T? Christy, I want you to help me here. What do we need to do for any vector which in this basis it can look like this, 1 minus 1? If we have a vector 1 minus 1 in this basis, how does this look like in this basis here? Ce do të bëjmë, Christy?
Duhet që mësojmë matriksin PK
Shumë e drejtë. Se do shëmësojmë matricën për këtë?
në koordinatët e XP.
Që të shkojmë nga kjo baza këtë, shkojmë të baza standarde. Pra du shkojmë këtune. Pra po shkojmë këtu, nuk kalon do nga këtu. Pra kesh shumë të drejtë, dhe shëmësojmë matricën për këtë. Sa është matricën për këtë?
2 minus 1, minus 1, 3.
Po, 2 minus 1, minus 1, 3. Shumë e saktë, që do të thotë atëherë të shëmësojmë të direkt. Kjo është, po e lëmë të shkojmë, do shkojmë për këtë. Shumë mirë, po pastaj. Jemi këtu dhe.
Do e paralizojmë me X me 5-7.
Jo, Kristi. Kristi, kjo 4 minus 1 ishte 5-7 këtu. Dhe 5-7 e baza standarde është ekuivalente me minus 25-60 e baza S. Dekord? Pra, këto të tre vektorët, këto janë një njëjta gjë, e parë nga tre baza të ndryshme. Këtu tani, këtu ku kemi të 1 minus 1-shin, në fillim do shkojmë te baza standarde, dakord? Tani nga këtu do të vim këtu ne. Si do vim këtu? Si vihet këtu, çfarë rrugë ka për të ndjekur, kush të sjell nga këtu këtu poshtë? Shikojmë Kristian poshtë.
The inverse.
Kush? Cila inverse?
E PK-s.
Jo, e PK-s të sjell këtu prapë, që PK-ja sjell këtu.
E PT-s, se më dhe.
Po bravo, Kristi, po thuaj shpejt. Kjo është PT inverse. Atëherë çfarë bëmë? Ne ishim këtu, u gjidëm lart me PK, se duket kjo, dhe nga këtu do vim poshtë me PT inverse. Je dakord? Dhe kjo është vektori X sipas bazës tënde. Këtë po pyesim ne. Në rregull?
Po.
Hajde bëjmë veprimet atëherë. Atëherë ne kemi këtu që sa është x square? X square është, më thuaj pak sa është x square?
1 minus 1.
Shumë mirë. Kjo është 1 minus 1. Sa është PK-ja?
2 minus 1, minus 1, 3.
Po, minus 1, 3. Sa është PT inverse?
Do gjem determinantin.
Shumë e drejtë. Fillim do gjem determinantin. Kjo është PT-ja në fakt, kjo është PT-ja. PT inverse. Kjo dhe e barabartë një përmi determinant. Sa është determinanti e saj?
Minus 5.
Minus 5, po. Atëherë kemi një pjesënim për minus 5, që shumëzon, që bëni ne? Ndroni vendin e dyshin me minus 1-shin. Kjo është minus 1.
Minus 1, minus 1. Minus 3.
Eksakt. Okej, atëherë shumëzojmë këtu. Kjo do dalë minus 1, minus 1, minus 3, 2, minus 1 e 5. Sa dhe kjo? Ndimo pak, Kristi, sa dhe sa shumëzimi këtu e dyjeve? Pra, rishtin e parë, do shumëzojmë këtë kolonë këtu. Sa dhe produkti këtu?
3.
3, po pastaj?
Minus 4.
Minus 4, po shumë saktë. Minus 4. Tani të shumëzojmë këtë matricën këtu me këtë. Pra këtu kemi minus 1, minus 1, minus 3, 2, që shumëzon minus 1 e 5. Kjo është e barabartë minus 1 e 5, që shumëzon çfarë? Sa është produkti këtu, Kristi?
Një.
Po.
minus 15.
Minus 9, minus 8, minus 17.
Po, 17.
Okej. Po i gjithë më. Atëherë sa dhe kjo? Kjo rezultati këtu. Kjo njështë minus njështë këtu, Kristin. E kjo është për gjithë klasën pastaj. Kjo është për me minus 1 të pestën. Okej. Dhe 17 të pestën. Kjo është vektori. Minus 1 pesta sa të bëjmë? Minus 0,2. Minus 0,2. 17 disim për 5 sa të bëjmë? 3,4. Pra këto të dy është e njëjta gjë. Më rregull? Kështu. Tjetër, një pyetje tjetër Kristi. Sa është nëse na jepet kjo x-këja, sa është vlera e x-it në bazën p, këtu. Pra kemi x-in sipas bazës k. Me çfarë do shëndzojmë? Pra Kristi? Që nga këja, duam shkojmë të s-ja. Si shkojmë nga këja të s-ja? Nga këja, do shkojmë të standard basic fillim, dhe pastaj do shkojmë të s-ja. Pra, nga këja të standard basic, me çfarë shkojmë ne? Kristi më dëgjon?
Po, po e kuptoj pyetjen.
Pa, më Kristi, a e bërë këtu? Ti e bërë këtu. Si shkollë ke toja? Nga baza kë, ti e këtu. Më thëmë, ti e këtu, si të shkosh të s-ja?
Do shëndzojmë koordinatët e s-bës?
Jo, Kristi. Shikoj të si të ndishka. Po të shikosh të që kemi vizatuar këtu në rast, nuk ka shans që ti të shkosh direkt nga baza B te baza S. Nuk shkove do ti nga këja te këtoja. Nuk përcjellë do të shuri. Qa bëmë? Në gjithmonë, kalojmë te baza standarde. Edhe unë këtë po të thëmë këtu. Këtu po thëmë nga baza kë, do shkojmë te baza standarde, nga baza standarde do shkojmë te S-ja, pse krejmë. Si shkojmë nga këja te baza standarde? Si shkojmë nga këtu? Kjo është qendra. Kjo është pika e referencës, mirë. Si shkojmë nga këja te baza standarde? Me qa shkojmë? Shqip qa është gjithë shkojmë?
Do vëmë koordinatën e kës me matriksin PK.
Po pra, më Kristi kjo është e këtëse. Ti po shomësh, kush të qonë ty, kush është i gjithë që qonë nga këtu këtu? Po këja. Atëherë këtu të shumë të në këtu. Okej. Pastaj, erdhën këtu. Nga këtu si të shkojmë të kjo, të s-ja. Të s-ja. Në qëse ne kalojmë nga këtu, shikoj për Kristi, nga këtu shkojmë me PS. Si nuk të thejemi mrapsh?
Me PS invers.
Eksakt. Pra ne do ecim mrapsh me PS invers. Që do thotë këtu, ne do shkojmë me PS invers. Dhe kjo do jetë pranuar me projeksionin e x-it mbi bazën S. E qartë tani? Jemi dakord Kristin?
Po, qartë.
Po mirë, pra mos një ngatrojmë të gjera. Shumë e zëmë, do shkojmë nga t-ja, do shkojmë te b-ja. Si mu shkojmë nga t-ja te b-ja? Pra nëse kemi një vektor që është i projektuar në bazën t. Pra kemi këtë x t. Si e sillim nga këtu tek b-ja? Ma tërgo pak?
Duke e shëmzuar matriksin PB.
Shumë e drejtë. Shëmzojmë me pt, edhe ku shkojmë me pt? Që të baza standarde këtu kartë përë.
Po.
Shumë mirë. Atëherë këtu e shëmzojmë me pt, pra e projektuam këtë vektorin të baza standarde, jemi këtu. Po pastaj si shkojmë të b-ja?
Me PT invers.
Me cilën?
PT invers.
Jo, pt invers vjen për.
PB invers.
PB invers po. Pra PB inversi në sjell këtu në vektor. Në rregull? Pra dhe çfarë? Ne themi kjo xt, po ta shëmzojmë me pt, shkojmë te baza standarde. Pastaj shëmzojmë me PB invers define, kjo është PB inverse. Dhe çfarë gjeni? Gjeni vektorin x siç projektohet mbi bazën B. Kështu. Pra, a është që ato Krisi, nuk e këtë pëzëm, po Krisi po e kanë fjalën me gjithë klasën, pa? Që do thotë, ne mund kemi shumë baza, për kërcym në njëra të tjetra, ne gjithmonë shkojmë fillim të baza standarde, pastaj përdorim një kërcim tjetër për tek baza ku duam të shkojmë. Më rregull? Tani mund sjell edhe një shtypim tjetër, për shembull kemi ne këtu, kemi nga T-ja, nga të shkojmë nga T-ja të shkojmë për shembull tek PB-ja. Është te baza B. Atëherë çfarë do shumëzojmë ne? Ne do shumëzojmë këtë vektorin minus 0.234, ta shumëzojmë me ata bëjmë të kjo pjesa një sekundë. Këtë ushtrimin, ose mund bëjmë dhe këtëre. We can do a lot of things, actually. Wait, okay. But I hope that things are a little more clear now. Okay, so let's do this example here, Christine. We have xt, which is minus 0.2, 3.4. So we have minus 0.2, 3.4. We multiply this with, so we are here, with pt to go to the standard basis, and the pt is 2, 3, 1 minus 1. This is 2, 3, 1 minus 1. And now, this means that this component, this is in the standard basis. So this is x according to the standard basis. That's good. We are here. So now we want to come back to basis B, and we need to find the PB inverse. PB inverse, we have it right here. Okay, so we need to multiply here with 1 over 3 times 1, 1 minus 2, 1. And this is equal to, let's find first, what is this value? So 2, 1, let's multiply with this vector. We get 2 times minus 0.2, this is minus 0.4, plus 3.4, this is 3. And then we have minus 0.6, minus 3.4, this is minus 4. Okay? So it looks like this is 3 minus 4. 3 minus 4, but we are talking about 3 minus 4 is this vector that I'm circling this in red here is this vector here, so that you can distinguish it, okay? So or we can do this one in double red, and then let's multiply this one with the PB inverse, 1, 1, 1, minus 2. This is 1 over 3, and this is going to be equal to 1 over 3 times 1. But here we have 3 minus 4, this is minus 1, minus 6 minus 4, minus 10. So we get here minus 0.3 and minus 3.3. Okay, so the answer here, or maybe I can better write this one, minus 1 over 3 times 110. Okay, so this is this vector which is here in red. This is this vector which was in red here in the basis T. Is it clear? Is there any question here in the class? Okay, so there is no question. We can move to a different discussion, a different topic. Yeah. Okay. So if you allow me, I'm going to erase most of the work that we have done here on the board, because yes.
Professor, the point of doing all this, I mean changing bases back and forth, what do we need it?
Say it again.
Why do we need to do all this to see the what's the point of changing bases?
Oh, this is a good question, and we need to do this change of basis because we often change the basis in order to simplify the problems that we are dealing with. Okay, so let's assume who is asking this question. I don't recognize you from your voice.
Lirido.
Oh, Lido, thanks for your question. And this is the best question of the day. Why do we do this change of basis? We do the change of basis because we want, first of all, we want to learn how we can do this, right? So the first question is that why do we do change of basis? Why do we do this? Why? Well, we do this because there is another question which is more fundamental than this, which is the following. Which one is the best basis? Which one is the best basis? Now, let me ask you, Irido, how many bases can you identify for R squared? Să bază care control.
I'm sorry, can you repeat again?
How many bases can you identify for R squared?
The standard basis, you mean?
No, other than the standard basis. Can you find the second basis for R squared? Yes. How many bases we solved in the previous example? We had 4 on the board. We had B, we had S, we had T, and K. We had 4 bases. But we can come up with an infinite number of different bases. Would you agree with this?
Yes, as many bases as we want.
That's true. We cannot find. So imagine now you have X and Y, and you can rotate them by 1 degree. And if you made a discrete step of 1 degree each time, you get 360 different coordinate systems. The magnitude of the vectors don't have to be 1 unit, they could be longer or shorter. So this means that you have a lot of bases, you have an infinite number of bases. But the question is, which one is the best basis? So this is the biggest question. How can we figure out one of the bases? So if we have an infinite number of bases for R squared, which one is the best? Okay? So let's think about this question, Diego, and we'll try to answer this one with you today. So which one is the best basis? And the moment we can answer this question, which one is the best basis, we would immediately transform the problem into the best basis. Okay? So once we get the answer, we have not learned this one yet. We don't know this yet. But the moment we learn which one is the best basis, we have to come back to the knowledge we are discussing today, and we have to do the change, okay? Is it clear?
Yes.
You don't? Okay. But now, what we are going to do next is that we are going to discuss the following topic. So, assume that we have a basis B, okay? And then we have another basis, standard basis. Let's assume we have a standard basis. This is standard basis SB. So far, what have we done so far, Gino? We have done the transform of the vectors. So we are transforming the vectors from one basis to another. How did we do it? So help me here, Gino. How would we transform this vector into the standard basis? What do we need to do?
We need to multiply with PB.
Exactly. So if we have a vector that looks like this, we multiply with PB, that's fine, we did it. So this is equal to the vector x according to standard basis, SB. Good. But now, we don't have only the transformation of the vectors. So we are looking how a vector looks into different bases. Another important transformation is the transformation of the linear transforms. So what are the linear transformations? They are transformations that can look like T is from R squared to R squared. Lido, give you a linear transformation. Come up with something random. If we apply a linear transformation on xy, how would you combine these two?
You mean x and y together?
Yeah, give me a linear transformation of T if we apply it on a vector xy.
X times y and y minus x.
No, don't use the multiplication, because if you use the multiplication, this expression is not linear anymore, okay? It is non-linear. We are dealing with linear algebra. So let's use only subtraction and addition.
X plus y and x minus y.
That's perfect. So you have two numbers, x and y, and you want to know the summation, and you want to know the difference. That's perfect. Now, this is a linear transformation. We know that any linear transformation, t of x, it can be denoted, so t of x, this can be denoted also with the matrix AX, right? So every linear transformation, it has an equivalent matrix A. So in this case, what is the matrix A here? Can you identify which one is the matrix A, Irina? So this is a matrix which is 2 by 2. This is the vector which is 2 by 1. And this matrix A, this is 1, 1, 1, minus 1. Are you following, Irina?
Yes.
Okay, thanks. So this is 1, 1, 1 minus 1, standard basis. Now what is very essential for us is to be able to have a look at how this matrix looks like in a different basis. Okay, so far we did a transition of the vectors. We are good at it, we learned, we are specialists. Now we want to transform not only the vectors, but also the matrices, which in principle this means transforming the linear transformation. How do we do it? Is that, first of all, we know that we can come this way using the matrix PB, right? And here, we can come this way with PB inverse. And here, we have the matrix A, and in principle, the matrix A, it represents, so I'm going to write the following. Matrix A represents the linear transformation LT in standard basis, okay? Now, we have another matrix, which is PB inverse times A times PB. This represents the linear transformation in the B basis. So, this is the major essence of what we can say, or what we can summarize for the basis change of the matrices, okay? So imagine for a moment that we can have a matrix C, which is equal to this multiplication. Pra ce shikojmë në lidhje? Shikojmë që për transformuar vektorët, ne do mjafton thjesht të shfrytëzojmë me njërën matricë. Je dakord?
Po.
Pra ç'a kemi ne? Ne mund kemi vektorin x, i cili mund të jetë në standard basis. Kjo është SB. Si e gjen vektorin x në bazën B, aty që ishte respekt lidhur?
Multiply by PB inverse.
That's right. So we multiply with PB inverse. That's perfect. Now, what if we have the vector in the basis B? If we are given the vector in basis B, how do we find the other one?
Multiply by PB.
That's true. We multiply with PB, so this is what we do. So it looks like to transfer the vectors, we just need a single matrix. Perfect. But if we want to transfer the linear transformations, we need to do something different. So we multiply with two matrices. This is all that we need to know regarding the what's the name? The transform of the linear operations or of the matrices. Now, I would like to start another example, but if you like, we can have a short break. Do you have any question for what we did so far?
Professor, just a question about the numbers in the matrix A. Are they randomly chosen here?
No, I asked Guido. He came up with this linear transformation. I represented this one as the, so Guido gave these numbers. So we can say they are random.
Okay, so, okay, good.
Okay, so far, we know that this is 1, 0, this basis, 0, 1, and this basis here, we don't know what it is. This can be minus 1, 2, and 3 minus 7, okay, so far, but I want you have a look at how the transformation of how we can transit from one basis to another for the linear transformations. But thank you for your question, Yoon, because I have to add something very important, which is the following. For any matrix C, which can be represented like this, then C and A, they are called similar matrices. C and A, they are called similar matrices. Okay? So I have to say this one, matrices. And now, imagine for a moment, if we have another basis S, okay? If you have another basis S that looks like this, and we know that we always go to the standard basis with PS, we come backwards with the inverse of PS inverse, and then how would the matrix A, how can this matrix A be projected onto here? Let's consider this as a matrix D, which is going to be equal to what? And let's do here the C. According to the definition we provided, we said that this C is going to be PP inverse times A times PP. And D is equal to what? PS inverse times A times PS. So in this case, what we can say is the following. C and A, they are similar matrices because they can be represented like this. Similarly, D and A are also similar matrices. So if this is true, this implies that the C and D are also similar to each other. Okay? Okay, we can give a short break here.